Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve past paper from EJU Mathematics 2018, second session, course 1, question number 2 from the first section. So basically, this is the second question from this past paper. If you want to watch the solution for the other problem on this paper, you can check link on the description box below. And also you can check my EJU playlist if you want to find out another past paper for EJU preparation. Before we start, don't forget to like, share and subscribe my YouTube channel if you like this video. In this question, let us throw one dice 3 times. So I have one dice and then I will throw it 3 times and let the number that comes up on the first throw be A. So A is the number from the first throw, and then the number of the second throw is B, and then the number for the last or the third throw B, C. Using this A, B and C, we consider the quadratic function f of x is equals to ax squared plus bx plus c. So the number that comes up from our dice is the coefficient of this quadratic function. The probability that b equals 4 and that the quadratic function f of x equals to 0 has two different real solutions is blah blah blah. So from this information, I can know that b is equals to 4. So b must be 4. That means my quadratic function becomes ax squared plus 4x plus c. And then this quadratic function must has two different real solutions. The condition for a quadratic equation to has two real solutions is the discriminant must be greater than 0. The formula of discriminant is b squared minus 4ac greater than 0. B is the coefficient of x, a is the coefficient of x squared, and then c is the constant term. So since my b is equals to 4, that means 4 squared minus 4 times a, I do not know the value of a, and also I do not know the value of c. So I will write it down as c. That means negative 4ac greater than negative 16. 4 squared is 16. If you move it to the other side, you got negative 16. And then if I divide the negative 4 to the other side, I will get AC is less than 16. Sorry, I mean 4. Don't forget to flip the inequalities because we divide our expression with a negative number. So AC less than 4. From this condition, we need to know how many possibilities are there. You need to remember, A, B, and C is the number that comes up on the dice. That means A is either 1, 2, 3, 4, 5, 6, and also C is also one of the value 1 until 6. If you see A times C less than 4, that means I have some possibilities. Let's say I will draw a table like this. The first possibility is A equals to 1 and then C is equals to 3. 1 times 3 less than 4. And then A is 1 and then C is 2. 1 times 2 is also less than 4. A is 1, C is 1. 1 times 1 is less than 4. And then if you think another possibility, of course, I can say that we still have another possibility. For example, now A is 2. A is 2 and then C is 1. 2 is not our answer because 2 times 2 is equals to 4. It is not less than 4. So 2 is not our answer. And then my last possibility is 3, 1. So there are 5 possibilities where A times C is less than 4. How about B? B is always B is always equals to 4. So if I add one more column here, B is always equals to 4. From this table, you can find the probability. The probability A is equals to 1 is 1 over 6, times C is 3, 1 over 6, times B is 4 is 1 over 6. Same thing for the other 4 cases. So, my final answer is 1 over 6 times 1 over 6 times 1 over 6 times 5. Since I have 5 different cases, each case has the same probability. So my final answer is 5 over 216. This is N, O, P, and Q. N is 5, and then OPQ is 216. This is the answer for the first question. For the second question, let us find the probability that f of 0 less than 453. So our objective is we want to find the probability that f of 0 greater than 453. First of all, we need to calculate how many cases are there such that f of 10 greater than 453. Same like here, yeah. We need to know how many cases are there. After we got the number of cases, just multiply it with 1 over 6 to the power of 3. That's our final answer. So, for the first case, I think I need to substitute x as 10 first, yeah. This is my f of x, and then if I substitute x becomes 10, I will get 100a plus 40. Sorry, this is not 4x but bx. So 100a plus 10b plus c. Now I will consider each of these possibility. The first one is when a equals 4 and b equals 5. As you can see here, if a equals 4, that means you have 400, and b equals 5 plus 50 plus c must greater than 453. That means c must greater than 3. How many cases are there when c greater than 3? The answer is 3 cases. C can be 4, 5, or 6. So, the number of cases when A4, B5, and f of 10 greater than 453 is 3 cases. And then, when A equals 4 and B equals to 6, once again, since A equals to 4, that means 100 times 4, you got 400. And then B is equals to 6 plus 60 plus C greater than 453. Then C is greater than 460. You move it to the other side. You got -7. So C must greater than -7. That means C can be 1, 2, 3, 4, 5, or 6. No matter what value of C you obtain, if A is equals to 4 and B equals to 6, then f of 10 must greater than 453, no matter what value of C you obtain. So for these second cases, there are 6 number of cases of ABC such that f of 10 greater than 453. By using the same concept, when A equals to 5, as you can see here, if A equals to 5, that means 500 plus A plus B greater than 453. That means since 500 is already greater than 453, so no matter, sorry, this is B and this is C, yeah? Since 500 is already greater than 453, no matter what number you obtain for B and C, it will always greater than 453. So, how many cases are there? We have 6 possibility for B and then we have 6 possibility for C. So the total cases are 36. So this one is 36. And also for the last one. Because when A is equals to 6, you got 600 plus B, 10B I mean, plus C greater than 453. No matter value of B and C you obtain, you will get a number that is greater than 453. So you have 6 choices for B, you have 6 choices for C. So the total choices are 36. That means f of 10 is greater than 453. We have 36 plus 36 plus 6 plus 3. 72 plus 9, we have 81 cases. While each case have probability 1 over 6 times 1 over 6 times 1 over 6. The same concept as the previous question. We already know there are 5 different cases. Each cases has probability 1 over 6 times 1 over 6 times 1 over 6. So, the probability that f of 10 greater than 453 is, just solve this equation. I will get divide by 3, I get 27. I can divide it by 3, I get 9. Wait a second, I think I miscalculate it, yeah. Divide by 3, wait a second, let me check. If I divide by 3, oh 2, this is 2. Divide by 3, I got 27. Okay, I divide it by 3 again, I will get 2. 27 divided by 3, I'll get 9. Divide by 3, divide by 3, 3. So my final answer is 3 over 8. This is for letter X and Y. Okay, that's it for this video. I hope you can understand my explanation, and I hope I see you guys on my next video. Bye bye.